express as a single logarithm. Log p to the base a plus 2 log q to the base a minus 3 log r to the base a. So a single logarithm basically means log x to the base a. So it's just one single logarithm. Now, from the properties of logarithms we learned in the previous videos, we said that if this is common between all of them, we can use some properties. So something like log xy to the base a is equal to log x base a plus log y base a. We derived this in the previous videos. You can check that out if you are a bit confused regarding this formula. So let's first get values for this and this because they have a coefficient. Another rule we learned that you can have something like n log a and x is here. So n log x to the base a is equal to log x to the power of n base a. This was something else which we derived in the previous videos. You could check that out. So we are using these two rules to solve this equation. So this is actually equal to log q squared base a. I am getting this by using this rule. If I were to bring this 2 down here, I'll be ending up with this. So I've just used this rule in the reverse order to get it. So my n is 2, my a is a, and my x is q. So I've just done that. I'll do the same thing with the log 3 log r base a. This is the same as log r cubed base a. I'm not accounting for the negative sign right now because we'll be using that as we go on. So this sum is essentially the same as log p base a plus log q squared base a minus log r cubed base a. Now we know some properties of logs. We know this one. We also know log x over y is equal to log xy base a. X over y base a is same as log x base a minus log y base a. We derived this formula. If you have a bit of a difficulty understanding this, you can look at our previous videos so that you'll understand everything. Now this is what we are left with and we need to solve this. So first of all, we can group these two terms. We can group these two terms to get this log p q squared base a. I'm getting log p q squared base a by use of this rule. This is log x base a, log y base a, log p base a, log q squared base a. So x is my p, q squared is my y, and I get this. So this times this is the same as p times q squared. The base will be same. Make sure that these bases are the same in order for us to actually solve them. So this is the numerical, is the value of this. So I'm left with this minus log r cubed base a. What will I do from here? I also know this rule. Log x base a minus log y base a is equal to log x over y base a. So I have a minus sign. That's why I'm using this rule. So this is equal to log pq squared divided by r cubed base a. One thing to make sure is that the bases have to be the same, and then after that you have your x and y. This is x over y, and because of the minus sign, that's why you're getting x over y. Because of the minus sign, I'm getting pq squared divided by r cubed. So my x is like pq squared, my y is like r cubed. So basically I'm translating this into this formula so I can get this. I've expressed this as a single logarithm because there's just one equation or just one term with log. So I've expressed this long thing as a single logarithm. The next question is to express 1 minus log ab to the base a as a single logarithm. How do I do this? It's again very simple. Just follow the rules of logarithms and it'll be very easy. So 1 minus log AB to the base A can be written as 1 minus log A base A plus log B base A. This has been derived in a previous formula. If I have log A and xy here, this is the same as log x base A plus log y base A. I'm just working backwards. So this is the product, and I've split them up into the additions of these things. So AB is the product, then A, and then plus B. So that's my additions. Note that you need to use the bracket so that you don't mess up on the signs. So this is the same as 1 plus log B base A. Now log A base A is equal to 1. We had derived that in a previous formula because A power 1 is equal to A. So this is how it works. So this is 1 minus log B base A. I've just expanded this by multiplying this by the negative sign. That's why you need to use the brackets so that you don't mess up on the signs. So 1 minus 1 cancels out to give you 0. So therefore your answer is minus log B base A. So you've expressed this as a single log, and therefore this answer is equal to minus log B base A. The third example asks us to evaluate 2 times log 5 base 10 plus log 2 base 10 minus 1. Again, this is a very simple question. If you know the rules of logarithms, it becomes very simple for you to solve. So first of all, we'll start by looking at the bracket. We notice that this and this is the same. Therefore, we can use the law of combining the logarithms. Log xy base A is equal to log x base A plus log y base A. Therefore, this is the same as log 10 base 10, because 5 times 2 is equal to 10. So this is for the 5 times 2. I've just used this, I've just translated this from this rule to get this. This will be multiplied by 2 because of the 2 here, minus 1. Now log 10 base 10, we learned that if you have log A base A, you actually get 1 because A power 1 is equal to A. So this is the same case. 10 and 10 are the same, so you get 1. So it becomes 2 into 1 minus 1, which is 2 minus 1. Therefore your answer is 1. So just by memorizing the rules of logarithms, it becomes very easy for you to solve questions. One more thing I want you to note is in the future, perhaps we'd be using notations like this. So here we have log 5 base 10. Actually, this can be written as log 5, just log 5. So we assume that the base here is 10, but it's only for this case. If I have log 15 as the base, I cannot write this as log 5. If I have log 35, I still can't write it as log 5. It only applies to 10. So log 100 base 10 is the same as log 100. Just make sure you know this so that it becomes easy for you to memorize and not get stuck whenever we are using these types of notations. So whenever you have a log 10 as the base, it's the same as without the base. So log 100 base 10 is equal to log 100.